All right, well, happy Wednesday, everybody. I hope your first week and a half or so at school has been going okay. I hope the homework's coming along okay. Um, so today I wanted to talk about functions and function writing strategies for in R, okay? I've already posted the second homework assignment, although I imagine almost all of you have been busy working on the first homework assignment, so you haven't taken a look at the second homework assignment. But as we go on, the homework assignments get a little bit more involved. And so the second homework assignment, you will be simulating some games of Chutes and Ladders, classic board game that you might have played as a child. Maybe not, but you'll be writing some functions to do it, and it will be a little bit more involved. And so that's what we have for that. And I wanted to give you some tips, or what I believe to be some good strategies as far as approaching writing a function and getting some complexity out of it. So first, we'll talk about some of these basic functions, which I imagine is review for most of you, and certainly you've had to write some functions already for your first homework assignment. But yeah, let's go ahead and take a look. And so when we write a function in R, we use the keyword function. We put in parentheses and any kind of argument names that we'll be using, and we assign it to whatever name that we're going to call this function later. And within inside the function, you have these curly braces to kind of group together the lines of code that you will be running. For style, I recommend indenting those lines, but it's not required. It's not required to run, but I recommend it. And inside your function block, you'll have expressions, lines of code that will run. And then probably your last line will be whatever object or output you want returned by the function. Okay, and so here's a very, very, very simple function. And here's a function of x where we're just going to take the value of x, multiply it by itself, and that will be the value that gets returned. And in some cases, if you only have a single line of code, you don't actually even need the curly braces. Now, I recommend that you use the curly braces every single time, and you and you do it as such, but technically it's not even necessary to do so. So here I've got the function x, and it takes x times x, and we're going to store it as the object f. Okay, I'm sorry, the function is a function of x. It takes the argument x, but the function is called f. And functions themselves are objects, so we can actually throw the function f into a list. And if I do that, I get double square bracket 1, indicating that this is a list object. And inside there, we have a function, x times x here, right? If we ask the type of f, we get a closure. And that is, that's kind of how R calls these things. Although, confusingly, if you ask what is the mode of this object, it comes back function. So it's just a little bit of, funny naming conventions here. And it's I don't know why it has all of these, why it has these different things that it calls it. Okay. Now, within the function, you can explicitly use a return statement, but you also don't have to. And if you don't use this return statement, whatever the last line that gets, the last expression in there that gets executed, that will be returned. And this is actually the recommended style for, if you look at most style sheets for R, and how you should write your code. And again, style is a matter of opinion, and that can be said just as far as what clothes you wear and what style you have there, or as far as the style you use for writing code. It is a matter of opinion. You'll have a lot of people agree, certain things are just not okay. It's not okay to wear socks with sandals and things like that. And you'll have things that people will say, you've got to indent your lines when you write your functions. But so most style sheets will have things like that. But whether you use a return or an implicit return, you'll have some difference in opinion, although most people will probably say, most R programmers will say this is the recommended style for R. When you are working with a function and it's going to return an object, it can only return one object. It can only return one object. And so if you want to return multiple values, and this is going to be most cases, you want to return multiple values, those values have to be grouped together into a single object. So if all of the values are of the same type, group them together in an atomic vector. That's fine. So here I've got a function f. F takes the value x and it returns the values x, x squared, and x cubed, but they're all grouped together in one vector. And so when I call f on the number 2, it returns 2, 4, and 8, and they're all grouped together in one vector. If you've got values of different types, you're going to have to use a list. Here, technically, the values are all the same type, but here I can still use a list. And I've got one list that it's going to return. It's going to return x is x, the square is x squared, and the cube is x cubed. And it returns those 3 different values stored together in one list. And an example of this is, I don't know if you guys are taking 102A right now, or maybe I'm going to say 101A right now. All of you are taking 102A right now, as we speak right now. But you might be also be enrolled in 101A, or maybe you've already taken it, or maybe you will take it in the future, or maybe you won't. But in that class, you will use LM to create your linear models, your linear regression models. And when you call LM, it returns an object. It's an object of type L, that's a list type. It's class LM, but it's a list type object. And if you actually look at the structure of the list, there's a whole bunch of different values. It contains, the residuals and the coefficients and this and that, and they're all stored in a big list. And that's how R handles the way functions return things. Is it just groups them, multiple values, into one list. When we're looking at the names of an argument that go into a function, those are the names that you use inside the function statements. So for example, here's, we're going to call function f now. We're going to create another function f. And this function has 3 arguments, x, y, and z. And these are the argument names. And so we can reference these arguments using the names x, y, and z later on in the function. And so as far as what this function does, it does paste 0, which just builds a string. Paste 0 means paste these objects together with nothing in between them. The default separator for paste 0 is nothing, the empty string. And so here we're going to paste the string x equals, and then whatever object x is, coerced into a string, comma y equals whatever object y is, coerced to a string, and z, and we're going to do that. And so when I call f with the arguments 1, 2, 3, 1 gets assigned to the argument x, which shows up in here. And so it gets x equals 1, and then it goes comma y equals, and then this value 2 gets assigned to the argument y, and y gets referenced here. And so we get y equals 2 and z equals 3 with the value 3 here. And so we get exactly what we asked R to give us, which is going to be a string that says x equals 1, y equals 2, and z equals 3. When you call the function, so here I just called the function with arguments 1, 2, 3, and it assigned them positionally. First value goes to the first argument x, second value goes to the second argument y, and third value goes to the third argument z. You can also call the function and assign the arguments by name. And you can say, I want the value 1 to get assigned to the argument z. I want the value 2 to get assigned to the argument x. I want the value 3 to get assigned to the argument y. And therefore, the function runs exactly as you wanted it. X is 2, y is 3, z equals 1. If you call a function with names for only 1 or 2 arguments, or positionally for this and that, R will do its best to match them. So it just tries, and R doesn't complain. You try this in another language like Python or something, you're going to run into an error message. But here R will do its best. And so we say, I'm going to call the function with y equal to 2. And then I just say 1 and 3. And so it assigns 2 to y. And then it uses positional arguments for the remaining ones. So it says, well, 1 goes into the first thing. This value over here goes into the remaining thing, and we get z equals 3. Here I say y is 2. I don't give it a name for 1. I give x equals 3. So again, R does its best, and we get x is 3, y is 2, and then the one that didn't get named goes into z. Here is the function, and I call it with 1, 2, 3, and I give it another argument, m equals 1. And this is finally R puts its foot down and says, I can't do what you're asking me to do, right? You've given me an argument, m equals 1, and I don't even know what to do this. So it gives us an error, and it says unused argument, m equals 1. What am I supposed to do with this? Okay. Now, here is another example. And so when you write functions, the argument values are required, the argument values that get used. Now, in my notes, I have really, the examples I do here, a lot of them are intentionally poorly written code examples. These are not going to be, like, don't use some of these examples as examples. They are examples to show you what happens in these weird scenarios. So these are generally scenarios you want to avoid, but it is important to understand what's going to happen in kind of these edge cases to kind of fully understand the rules, right? Like when a law is written, you have to think about all of these kind of edge cases where somebody's going to try out this one thing, and then the judge has to figure out where's kind of the boundary between what this law actually means. And similarly, I'm writing a bunch of kind of examples of stuff of some weird things, so you can kind of see what actually happens. So here's a function, and the function is defined with arguments x, y, z, and w. So we have 4 arguments in the definition of the function, but within the function, there's only one line of code, but this one line of code only uses the values, the variables x, y, and z, and it doesn't make use of the variable w. So what happens? So if I call the function f with the values 1, 2, 3, and 4, R says, great. I've used x is 1, y is 2, z is 3, no problem there. Here I call the function with just the arguments 1, 2, 3. So x is 1, y is 2, and z is 3. I didn't give it a value for w, but when R runs the code, it runs this. It doesn't see a need for w. It doesn't run into a problem. It doesn't complain, and life goes on. But over here, I've got the same function, but this time, when I assign values, I give x is 1, y is 2, and I say w is 4, and I didn't give it a value for z. I did not give a value for z. And so now R says, I can't run this line of code, right? It comes in, it calls the function, and it says, all right, we got a value for x, we got a value for y, we got a value for w. Okay, now with that, try to run this next line of code. And it tries to run this, and it says, I can't run this. It says error in this line of code. Argument z is missing, and technically the error message goes on, and it says argument z is missing with no default assigned, or with no default value, or something like that. And that just says, well, I can't do this because I don't have a default value. Let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter D. D as in dog. D as in dog is our first view quiz answer. So when you write a function, you can provide default values. Okay, we can provide default values. And so here, the function f, it's the same exact function, but now I've given it default values. So rather than just x, y, z, I say we have x and give it a default value of 1. Y also gets a default value of 1, and z gets a default value of 1. And so now when I call f with no values provided as for the arguments, it uses all of the defaults. It's going to use 1, 1, and 1. and it comes back with x is 1, y is 1, and z is 1. Here, I call f with the argument 2. 2 gets plugged in positionally, and so it goes to the first argument. So x is going to get the value 2. And so when it prints out x is 2, and it uses the default values for y is 1 and z. Y is 1, z is 1. Here I say take the number 3 and assign it to z, or z gets the value 3 as far as the arguments go. And so it uses the defaults for x and y, 1 and 1, and z gets the value 3. And so that's how default arguments work as far as functions in R. It's an important thing to note, and we will talk a little bit more about scope on Friday, but it's important to know that values that are created inside a function only exist inside the function. And in general, you should not try to change values that exist in the global environment from within the function. If you do want to try to get a value out of the function, it needs to be part of the returned object. So if you want to get a value out of the function, it needs to be part of the returned object. So here's just a very simple example. I'm going to have x get the value 10, and this name x is defined in the global environment. Here I create a function f. And inside the function f, we're going to, this function f takes in an argument called x. We're going to do x plus 55 and assign that value to x. And we're going to return the value x. Okay. Now it's important to know that the x inside the function has nothing to do with the x outside of the function. These are two objects that happen to have the same name, but one exists inside this function and the other exists out in the world. Okay. And so this is what we have. Okay, so when we have f of x, okay, when I call f of x, we are calling this x. What is this x? This x exists inside the global environment. So we are calling f of 10. Okay, 10 gets passed into the function right here. And so we're going to have the value 10 show up. 10 plus 55 is 65. That gets assigned to this object x. We return 65. And so f called on 10 returns 65. What is x in the global environment? That was not affected at all. And that value is still 10. Okay. So again, x in the global environment is 10. I call f using this value x, and it returns 65. X is still 10 in the global environment. Now, if I wanted to change this value x in the global environment, I can do it, but I have to do it explicitly. I have to say, take f of x, which is going to return 65, and store it into x. Okay, well now x is the value 65. Functions are an important thing about doing stuff in R, okay? A lot of times as you are working either on some project, some data analysis project, something, you're going to find yourself having written some code, a chunk of code, and then you find yourself, do I need to copy and paste this code somewhere, right? And then you end up saying, okay, you know what? I actually need to do the exact same thing again. I just need to change it from, this variable to this other variable, okay? So you take that piece of code, you copy it and you paste it, and then you just change the names of the variables to something else, right? And you say, and then later on you go, oh, you know what? I actually need to do this one more time or another time. And then you're going to just copy that piece of code and you paste it and then you change a few more variable names. This is, I think, a common thing that happens, during projects and stuff. And the first time you copy and paste it, fine, okay? The second time you copy and paste it, you should start thinking of writing a function. And by the time you have to copy and paste it, the third time, right? So this is my guideline. Don't copy and paste the same chunk of code and alter the variables more than 2 times. By the time you have to copy and paste it a third time, then you should turn this thing into a function, okay? Because when you turn it into a function, then every time you run it, it's going to be doing the exact same thing. Okay. And later on, what often happens when you do this copy and paste thing, you might copy and paste it 3 or 4 times. And then at some point you go, oh, you know what? I actually need to do something a little bit differently, right? I need to modify this thing. And then you have to go through and you have to find every instance where you copied and pasted this, and you have to make that change multiple times. And then you just open yourself up for mistakes and problems later on. So my advice, it's better to change code in one location than try to change copies of the code everywhere. When you name your functions, pick good names. Now, all of my examples in this lecture so far, I've been using names like F or F2. These are terrible names for functions. Don't name your functions F or F2 or something. Give it some context, right? Name your function with a description of what it's going to do. It's going to my function is going to do a prime factorization or something like that, right? If the function returns a true false value, then your function should have a name that looks like a question that could be answered with yes or no. So for example, is it character? Yes or no. And then it makes sense to do true or false. Is prime will return true or false because it's asking is this number, is whatever is going in there, is that prime? Okay. So think something like that where you can get kind of a yes, no answer. And that would be a good name for a function that returns a true, false value. So let's get into kind of the bulk of today's lecture, which will be on function writing strategies. And so you've already had to write a few functions for this first homework assignment. And I imagine as you've been working, you've encountered errors along the way. And that is a good thing, okay? When you encounter errors in R and you experience a bit of frustration in trying to figure out what's going on, this is part of the learning experience. And I've given you this first homework assignment, and I'm going to give you some function writing strategies, and you feel like, oh, you should have given this earlier. Well, the function writing strategies you can implement for your next homework. And I think, you know, and I was reading through your Campus Wire. And by the way, thank you guys for having excellent discussions on Campus Wire. You guys are helping each other out. You guys are upvoting each other's answers. And as far as I can tell, nobody's breaking any kind of rules about oversharing code or anything like that. So, so I appreciate you guys helping each other out in a way that is, yeah, I think encouraging people to think about you know, how to approach the solutions without, you know, explicitly writing out the thing. So good job to all of you who are participating on Campus Wire. And then I know some of you are nervous about participating on Campus Wire. You feel like you don't have much to contribute or something. I still encourage you to just try to write an answer, and perhaps it doesn't get that many upvotes or anything. Don't be discouraged. Just put yourself out there a little bit, okay? But as I'm reading through Campus Wire, and you know, people are encountering different kinds of errors and different kinds of issues, I hope you can learn from the errors that you are encountering, and you can help try to figure out what is causing those errors. And hopefully with today's kind of lesson talking about strategies for writing functions, this will give you some ideas here. Okay, so here we're going to just write a simple algorithm that will sort values. Okay, and so the way we're going to just be writing a function for that will perform a bubble sort. Okay, and so the way bubble sort works, it's an sorting algorithm. It's not the most efficient sorting algorithm, but it's a simple one and it works. And the way it works is it just compares. It takes, you know, a vector or a list. It compares every adjacent pair of values, and if those two values are not in the correct order, it's going to swap them so they are in the correct order, right? So if we want to go from least to greatest, it's going to just look at two numbers side by side. If they're not in the correct order, it's going to swap them and put them in the correct order. And then it's going to go to the next adjacent pair of values. And if they're in the correct order, it leaves them. If they're not in the correct order, it swaps them. And it just keeps doing this, and it does multiple sweeps until there's no more values to be compared. So here's an example. Let's say we have this vector 5, 1, 8, 2, 4, 5, 1, 8, 2, 4. And so it's going to start by comparing the two values next to each other, 5 and 1, and says, are these two values in order? They are not in order, right? If we want to go least to greatest, 1 should come before 5. So in this case, we swap the values 1 and 5. Okay, we swap these values, and that's it. Okay, then we compare the next two values that are next to each other, 5 and 8. So now I have 1, 5, 8, 2, 4. And inside this thing, I look at the next two values, 5 and 8. Are they in the correct order? They are in the correct order, so it's not going to swap anything. Then it looks at the next two values, 8 and 2. Are these two numbers in the correct order? They are not. 8 is bigger than 2, so it's going to swap them. And so we get 2, 8. So now we have 1, 5, 2, 8, and 4. And lastly, it looks at the last pair, 8 and 4. Are they in the correct order? They are not in the correct order, so it swaps them. And when you do this by kind of just swapping each value, and you do an entire sweep this way, the largest number will get pushed all the way to the right, because somewhere along the way, you're gonna encounter the largest number. And if that largest number is not already all the way over to the right, every time you compare it to another number, you're going to say it's not in the correct order, so it needs to get swapped, right? So this number 8 is not in the correct order, so when it's compared to the 2, it swaps, and then it gets compared to the 4 and it gets swapped. So the 8 gets picked up and it gets pushed all the way to the right here. Okay, and so now our vector is 1, 5, 2, 4, 8. We do this again. Okay, so now 8, we know this is in the correct position, so we can lock position 8. 8 is now in the locked position. And so now I don't need to compare anything against 8. I know it's in the correct order, so I'm going to just look at the first two values, 1 and 5. Are they in the correct order? They are not. They are in the correct order, so I leave them. Okay, 1, 5. I look at the next two values, 5 and 2. They are not in the correct order, so I'm going to swap them. So this goes from 1, 5, 2, 4, 8 to 1, 2, 5, 4, 8. Okay, and then again, we look at the next pair of values, 5 and 4. Are those two values in the correct order? They are not. So we swap those positions. Okay, and now we get 1, 2, 4, 5, 8. Okay, and so, and we stop here. We don't compare 5 and 8 because we already know 8 is in the correct position. So now we're going to, at the next spot, we're going to lock 5 and 8. And technically, at this point, the vector is in order. 1, 2, 4, 5, 8. It is in order, but the algorithm doesn't know this. All the algorithm knows is that 8 is in the correct position and the second value is in the correct position. So it's going to continue kind of running, all right? So it's going to look at this. It's going to say, all right, are 1 and 2 in the correct order? They are, so that it's not going to swap. Are 2 and 4 in the correct order? They are, so it's not going to swap. So now it knows 4, 5, and 8 are in the correct position. And it does one more comparison. And it says, are 1 and 2 in the correct order? They are, so it doesn't swap. And now we know all of the values are in the correct order. 1, 2, 4, 5, and 8. Okay. Does that kind of make sense as far as how this bubble sort algorithm works? Here's a little animated GIF of the bubble sort algorithm. And unfortunately, it's just a little bit painfully slow to watch on Wikipedia, but it's comparing two numbers, 6 and 3. Are they in the correct order? They aren't, so it swaps them. Goes to the next thing, 6 and 1. Are they in the correct order? They are not, so it swaps them. And it goes to the next one, and now it encounters the very largest number, okay? 6 and 8 were in the correct order, so it moved on. 8 and 7 weren't in the correct order, so it swaps them. And because 8 is the largest number, every time it encounters the next number, it's going to swap. And eventually 8 gets pushed to the very last position in the correct spot. And once it does that, it gets pushed into the last position, we lock it in and we start over. We start at 5, 3, we keep swapping. And this is going to encounter the second largest number, 7, and it's going to push 7 all the way to the end, right? So it keeps swapping, 5, 1, and it keeps going. 5, 6 is in the correct order, and it keeps moving. 6, 7 is in the correct order, it keeps moving. 7 is the next largest number, so when it encounters 7 versus 2, it's going to get pushed to the right. 7 versus 4, 7 gets pushed to the right. And that's that. Okay, and we're not going to watch this whole animation, but you can see how it now locks these positions in place. Okay. So when you write a function, what you should do is you should think, can I break down my task into smaller tasks? Can I break in? And big tasks can always be broken down into smaller tasks. So as far as this bubble sort algorithm, one thing is we've got to take 2 adjacent values and swap them if they're not in order. Okay, 2 adjacent values and swap them, right? So this itself can be broken down into, well, can we just compare 2 values? Is one bigger than the other? Fine, okay. And the other thing is, can you swap 2 values? All right. And then after that, we got to perform multiple sweeps on the vector. And every time we perform a sweep, we can do one fewer comparison. And we'll get into this. Okay, so this is my piece of advice. Do not start writing a function. And probably, and I think many of you encountered some of this stuff because you started writing a function right away and you encountered some issues and errors, and a little bit of that pain is good because again, it's a learning thing. But let's say we just have this vector x 5 4 3 2 1 5 4 3 2 1. Can we just swap these first two values? Can we swap 5 and 4 so we get 4 5 3 2 1? That's step 1. Can we just be able to do this? Swap 4 and 5, 5 and 4 here. How do we do this with code? Okay, so here I'm going to say, well, let's try writing a function. Okay, this is not the strategy we should do, but if I say I'm going to just start writing a function. Let's just see if I can swap the first 2 values. Here's x. X is, we're going to take the second value of x and put it in position 1. We're going to take the first value of x and put it in position 2, and then we're going to return x. Okay, so I say x is 5 4 3 2 1, and then I run the code, swap the first 2 on x, and this is what I get. I get 4 4 3 2 1. This is not what I want. I want 4 5 3 2 1. I started off with 5 4 3 2 1. And I want 4 5. I just want to swap those first 2 values, but I end up getting 4 4 3 2 1. Okay. And chances are when you write a function, you're not going to get it 100% right the very first time. Maybe, but a lot of times you won't. And when you run a function, remember all of this stuff is happening inside its own little environment, inside its own little scope. The values inside the function are not observable from the outside. And it becomes really difficult to debug this. You have to kind of read each line of code inside the function to truly understand what is happening. And that makes debugging hard. So instead of writing a function, I recommend just working straight in the global environment and writing code in your global environment so you can see what is happening. And only after you get everything working well in the global environment, then you can start writing a function. So number 1, delete everything out of your global environment, right? You hit the broom or the sweeper icon in the corner on RStudio, or you can run this line of code, remove list equals ls, and that's going to remove everything from your global environment. Here I assign the vector x 5 4 3 2 1. And this is the very first thing I'm going to do. Okay, so just right now, while I'm in the global environment, I'm going to say take the second value and put it in the first value, because this is what I want to do. I want to swap the first and second values. I just want to swap those first 2 values. So I'm going to say, take the second value and put it in the first position. And then let's see what happened. I print out x immediately after, and we get 4 4 3 2 1. And then if I say, well, take the first value, 1, x1, and put it into the second position, and I print that out, I still have 4 4 3 2 1. And now I can see where I went wrong. When I started off with 5 4 3 2 1, but this line of code took the second value, the 4, and it overwrote the first value. And that first value, which was a 5, is now gone. It has been lost. Okay. And so by working in the global environment and checking immediately what happened to x right after each line of code, after doing this and seeing x, I can see, oh, you know what? I actually need to save this 5 somewhere. I need to save the 5 somewhere so I can use it later. So here, let's delete everything out of the global environment. We've got x is 5 4 3 2 1. And now I'm going to take that first value, store it into a temporary position. Now I will take the second value, put it into the first value. And then I'll take that temporary number and put it into the second value. And now when I look at X, it is exactly what I want, 4, 5, 3, 2, 1. I held on to that first value and I can put it back into here. Okay, so this has done the very, very basic thing of just taking those first two values and swapping them. And we can see, you know, again, by working in the global environment, we can see what's going wrong and we can fix this up. Let me go ahead and give you your second view quiz answer. Today's second view quiz answer is the letter C, C as in cat. C as in cat is your second view quiz answer. Okay, so let's just keep trying this out with other sets of code or other examples. So here X is the vector 1 through 8. And when I run this just these 3 lines of code, it's going to swap those first two values and now it goes 2, 1. Now we go, oh, you know what? It did what we wanted to do. It swapped the first two values, but we don't actually want it to swap the first two values if they're already in order, right? So let's make this swap conditional. Only swap these first two values if the first two values are in the wrong order. So what we do is we write a conditional statement. If x1 is greater than x2, then swap them. If the first value is bigger than the second value, swap them. Otherwise, don't run this code. So we try this out. So we do 5, 4, 3, 2, 1. Those values should swap. And when I run it, now they swap. It goes 4, 5, 3, 2, 1. Whereas over here, I try it out. Again, delete everything out. Just do another example. X is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 should not swap. We're not swapping those values. And when I run the same line of code in the global environment, indeed, X does not swap and it leaves it as 1, 2, 3, 4, 5. So again, key here is we're working in the global environment. We're trying out different test cases just to make sure that this little chunk of code is working as we want it to do. And so right now we have a conditional check, and then we're going to do a swap. Okay, so what we want to do is we want to now do a sweep. Okay, we want to sweep comparisons for kind of all positions in a vector. So what I'm going to do, rather than just looking at swapping the first value and the second value, I want to say, okay, let's see if we can swap the second and third. See if we can swap the third and fourth, and the fourth and fifth, and so on and so forth. And so I'm going to take this same chunk of code that I've been working with, and I'm just going to throw it inside a for loop. I'm going to put it inside a for loop. And we're going to say for I in sequence length, so we're going to take the length of our vector, and we're going to say for I in the sequence length, which will go 1 through 5. And in here, I'm going to replace every instance of 1 with I, and every instance of 2 with I plus 1. Okay, so for the first iteration, I will be 1, and this will be 2. And we'll look at, you know, it'll be equivalent to this. And the next iteration, I will be 2, and I plus 1 will be 3. And it'll be like doing a swap, and we're looking at the second and third. Is that okay? Going from just using the actual values 1 and 2 and turning it into I and I plus 1. Okay. All right. So let's see if this works. Okay. So I'm taking this. I try running this for I in sequence length of X. And immediately right off the bat, I run into an error. It gives me this error, missing value where true false needed. And it tells me it's happening in this line of code. If X of I is greater than X of I plus 1, it's saying it's encountering a missing value here in this if statement. So one of these things or both of these things is missing. So let's just check out what's going on. And again, this is the advantage of what happens when you're working in the global environment. If we were working inside a function, all of these values are created inside of the function. As soon as the function encounters an error, it's done. We can't see those values. But by working in the global environment, I can actually see what's going on. So I can say, well, what is I? Well, I right now is 5. Okay, what is X of I? X of I is 5. What is X of I plus 1? Well, X of I plus 1 will be the 6th value in X. And again, X right now is a vector of length 5. And so when we ask for the 6th value of X, we're getting a missing value. And that's why we're encountering an error. So I'm asking, is the 5th value greater than the 6th value? Well, there's no 6th value. So that's why I'm encountering an error. And so we look back at our code here and we say, oh, you know what? Sequence length of X is going to produce a vector. Because my vector is length 5, it's going to produce a vector that goes 1, 2, 3, 4, 5. And technically, I only need to do 4 comparisons. I only need to compare 1 and 2, 2 and 3, 3 and 4, and 4 and 5. I don't need to compare 5 with the 6th position. So my I only needs to go have a sequence length of the length of x minus 1. Okay, so my sequence length is not length x, but rather length x minus 1. Does that make sense, what's going on here? So this adjustment, and again, we can encounter and figure this out because we are working in global environment and we're able to figure out or pinpoint exactly what the value of I is and where we're encountering these error messages. So now that I've changed this to sequence length of x minus 1, I'm still working in the global environment. I'm still haven't written a function, but I'm going to just try it out. We got x is 5, 4, 3, 2, 1. Let's run this code, and it goes 4, 3, 2, 1, 5. Okay, and indeed, it has pushed the largest value 5, got pushed all the way to the right. That does exactly what we want it to do. All right, so let's just try this out. Try it out with different cases just to make sure that this code is working. So here's another vector. 1, 2, 5, 8, 3, 6. We run it through the exact same code. 1, 2, 5, 3, 6, 8. The largest value got pushed to the right. Let's take a vector of length 10, put them in random order. Okay, we run it through this, and indeed it has pushed the largest value, 10, all the way to the right. And that's what we want to see. We want to see the largest value get pushed all the way to the right. So now that we've done this, all we have to do is just run this multiple times. Okay, we just have to run the sweep multiple times. And so here I can start off with the vector 5, 4, 3, 2, 1. I run the code one time, and it pushes 5 all the way to the right. I run it again, and now it has pushed 4 all the way to the right. Okay, I'm just running the exact same code. And so technically, how many sweeps do I have to perform? I need to perform the length minus 1 number of sweeps. So I'm going to just take this exact code that I've been running, and I'm going to just put it inside another loop. So I've got kind of a nested for loop. Okay, so I've got the code that I've been running, and I'm going to put it inside another for loop where it's basically each time I run it is 1 sweep, and I'm going to just run how many sweeps. I'm going to run S of them, and I'm going to run it. I'm going to do the length of x minus 1. So basically four different sweeps. We're going to run this 4 times. So for S and sequence length of x minus 1. And if I run it, it goes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's actually working. Okay. But there's a bit of an inefficiency. Every time I perform a sweep, it runs through the entire vector, and that's actually not necessary. Every time we perform a sweep, we don't need to run through the entire vector. We can lock in certain positions, and we don't have to do comparisons anymore, right? So the first time I ran it, I can lock in the position 5, and then next time I only need to do 3 comparisons. So the first time, length 5, I did 4 comparisons, and it pushed 5 all the way to the end. The next time I only need to do 3 comparisons, and the next time I only need to do 2 comparisons. So each time I can lock in one more time, and I don't have to do all of these comparisons. So, so the first time we move through the entire vector, which will be length x minus 1. The second time we perform a sweep, we don't need to go through the entire vector. We only need to move through length x minus 2. And then the third time we run through length x minus 3. Okay, so each time we can take the vector, and we can reduce how many times I have to do a comparison. So all this is going to do to kind of make it a little bit more efficient, I'm going to have a variable called locked. How many positions are locked? We're going to start in with none of the positions locked. Okay, and every time I run a sweep, okay, the number of comparisons I need to do will be sequence length of x minus 1 minus how many values are locked. Okay. And every time I complete a sweep, I'm going to increase the number of positions that are locked by 1. I'm going to do locked plus 1 and store that back into locked. Okay. Now I could probably save a few lines of code by being, creative with my names, and I can do I minus S and things like that. But I'm not going to worry about that, or length of X minus S. But here I've got locked is 0. It starts off at 0. None of the values are locked. But every time I run it, one more position is locked. And therefore, the sequence length that I have to do will decrease by 1 with each sweep. Does this kind of make sense? What's happening here? Let me go ahead and give you your last view quiz answer for today. Last view quiz answer today is E as an elephant. E as an elephant. E as an elephant. Thank you for your thumbs up and your head nods there. So I appreciate that. Okay. And again, this entire time, I haven't written a function. I've just been working in the global environment. Every time I'm kind of clearing it out to kind of just make sure this thing is working. And so let's just try this out and see if this this works for other vectors. Okay, I got notes, and this is where I say, you know what, we're doing sequence length rather than doing 1 colon this. And we've already talked about the problem of doing 1 colon length and stuff like that. So here we're going to do sample 40. A vector of length 40 in random order. I run through the code that I've written, and indeed it sorts it 1 through 40. Okay, so it seems to be working. It seems to be working. So let's make this a function. So I'm going to just take this code and throw it into a function. So this is the code I've written. I throw it into a function. I'm going to call this bubble sort, function of X, 0 positions start off locked. And we're going to have one loop inside of the other. This loop performs sweeps. We're going to perform the length of X minus 1 number of sweeps. And let's try this out. Take 100 values. Let's randomly shuffle them using sample 100. And then I say bubble sort X. And then nothing happened. So let's look at our code. What did we do wrong? Okay. What we did wrong was we don't have a return value. Right? The function didn't return a value. So all we have to do now is we just add X and just say return that vector X, return that vector X. Okay, and so now it will work. And so here, a random vector, 100 values, and I say sort it. And indeed, it sorts it. Okay, so this looks good. Okay, so again, the recap of all of this is break down your task into smaller steps, and don't try building your function right away. Try working in the global environment. Okay, write your code and test it out. See if it works. Try it with different test cases, and if something breaks, check the values that exist in the global environment, and see if you can get it to work. All right, clear your environment every single time. That way, values that you've stored and created previously don't come in and you think that these values are available to you every single time. And test your code thoroughly before moving on to kind of the next step. Okay. A couple tips on efficiency. Inside RStudio, I often recommend writing your script or your code inside the script, and then you can hit the source button and it will execute in the console. And when things encounter errors, you can say, well, what is the value of X? What is the value of X at I plus 1 and things like that when you do encounter some kind of error or some kind of message here. And you can always check in the environment to see what your values are currently at that moment in time. Homework 2 has been posted, and I doubt many of you have taken a look at it. But the remaining slides here, they are here for your benefit, and I encourage you to go through them. I break down one of the tasks. So one of the tasks is to draw the game board for Chutes and Ladders. Okay, and I just say, well, you know what? How do you even just start by drawing a grid? Okay, how do we draw a grid? And so we want to keep the code flexible for different columns and rows. And so I just say, all right, well, how do we get started? And so I just write a few lines, create a new plot. And here's how you draw a segment. And how do you draw a horizontal line segment? Okay, it might look like this. How do you draw a vertical line And if you want multiple line segments, how does it go, right? And you here, here's multiple line segments, here's some vertical line segments, and so on and so forth. And I've kind of broken it down, and you are welcome to use this code to get started for homework 2. Okay, so obviously this code that I've provided for you, you can use in homework 2, and as you get started there, hopefully this will be helpful. Okay. Other than that, we will end here for today. Have a good rest of your day, and we will see you guys on Friday. And I'll also have office hours starting at 12:30 and later on tonight at 5 o'clock. So so some of you, maybe I'll stay office hours. If not, have a good rest of your day, and we'll see you guys on Friday. All right, thank you, everybody.